Hello, everybody, and welcome. I'm glad you're here. Welcome back. Enjoy. Have fun. I am talking about a heavy lift drone, mostly on the topic of autonomy, and I'm going to get to that. But I had the intuition that there's a couple of things I should talk about first before we start getting into uh, the autonomy issue. I think an important question here is the group of people who say, yeah, well, Dr. Gray, look, this drone you're talking about, number one, is completely impossible. And number two, nobody cares. And I just was thinking, it doesn't seem to me by math that it's completely impossible, particularly since nothing about it has ever been tested. All I really did is took an airplane and put this vertical horizontal thrust bar on the two sides of it, and then I put a thrust bar on the back, and it does have tilt rotor, so the rotors can be tilted. It runs off of these bent axis hydraulic motors, and it's powered by two of the CTS 800 turboshaft helicopter jet engines running bent axis pumps. And the thing that controls it, let me rephrase that, the thing that controls the rotation output of these motors is this valve system. And none of this has been tested. So I don't know why it's so obvious that it won't work. This distance is 6 feet, and this distance is 5 feet, and this distance is 17 feet, and this thing can lift 1,000 pounds of payload, in addition to which 600 pounds of fuel. The drone weighs 3,000 pounds, so this drone can take off and go straight up to 500 feet in 30 seconds using 8 pounds of fuel. And then it can begin a tilt rotor and get itself going in a airspeed translational concept where the wings are now supporting it, and it can fly at 125 miles an hour using 136 pounds of fuel per hour, which gives it a 3-hour flight time. So it has a 370-mile range. It just seems to me, if you said to a military person, hey, we don't want you to buy, well, we want you to buy 1,000 of them. Of course we do. But do you even want to buy one? I think the military would go, yeah, we would like to look at this thing. It doesn't even need a runway. And it'd be like, nope. It can land on a runway if you want it to, but it doesn't need one. And so it's not that obvious to me that this is of no interest. And there isn't any drone like this. Now you can see I've got it in Autodesk Fusion. Autodesk Fusion is a very nice, full feature 3D CAD drawing program. This is out on the cloud somewhere. I created it in SketchUp. The FBX file for the plane is 300 megabytes, and the FBX file for the controller is 140 megabytes. I saved this whole Fusion file on my hard drive. It's 27 megabytes. But anyway, I just thought it was interesting that I can get it into Autodesk Fusion. And we're going to talk about some stuff on the topic of how do you go about demonstrating that this is for real or not. And then there'll be a series of these lectures on this topic explaining what we're talking about. And then we're going to have a story where this thing saves the day, because I think this will help military soldiers not to be injured. But I'm not quite ready to start that story yet. I wanted to do a little more science. So that's our next step. All right, and this is in Keyshot. I need a drone to be created that is a heavy lift drone. And you might say, well, why do you need a drone to be created? Because I need to get performance values from these propellers to find out what is it that the propellers need to be doing for a heavy lift drone, so I can then go and do that kind of testing on these hydraulic motors. And it doesn't make any sense to try to establish that these hydraulic motors are more than adequate to propel a truly heavy lift drone if I don't know what it is they need to be doing. So that is why I did this, and that is why I need a heavy lift drone. And we're going to talk about that, because we don't have to start out with a hydraulic heavy lift drone. We can do an electric one. Everybody seems happier with that. And of course, there's a couple of things I always want to try to show you. And let's just take a look here. This is a short-eared hunting owl in the snow from Bing. I see this as, why not? Me trying to get across this point. Each of these little white dots is somebody who works with drones and is quite confident that I'm wrong and it won't work and it's not worth even checking, even without building anything, because there's no point. And I don't mind, I've been wrong before, but it's hard to be wrong on the basis of somebody that never even looked at the parts that you're talking about. So, and I think it will be a benefit to the military. It's worth it. I think it might be they will pay for it. Okay. I always like to include hello and welcome. I am glad you're here. Have a good time. This is enjoyment. We're not trying to prove anything, and none of us are employed doing this. So we're not working. We're just enjoying. I have a website. You go to the menu. You don't go here. Yes, you do go here. Not about a piston robot, because the drone is not a robot. And then there's a sub-page, heavy lift drone. And that's where I talk at my website about the heavy lift drone. I always want to, particularly this equipment is big enough to really hurt somebody. So, but the truth is, any physically real object could hurt somebody. So if you are managing a physically real object, my advice is to manage it in a manner that is legally allowed and reasonable and safe. And if you can't manage it in that way, my advice is do not create it as a physically real item. And so I want to talk about making a drone that's a smaller drone. These are drawings with the 6-foot diameter propellers that I wanted for the big drone. These can create 933 pounds of static thrust each. But I want to make a littler drone on the same frame. This is 14 feet long, and it's about 12 to 14 feet wide. But we're going to put a 5-foot propeller on here. And the motors, instead of creating 233 horsepower, they're going to create 80 kilowatts, which is about maybe 150 horsepower. And the thrust of the propellers will be 225 pounds of thrust. And the reason we're going to make that littler drone is because that drone can be created with electrical equipment that already exists. It's for sale. I'm going to show you all the websites. And you might say, and so who is going to do this? And my reply is, there's always a PhD student in aeronautical engineering that's looking around for a topic. And I've done the research thing. I'm published. I have a published paper in my name in a prestigious scientific journal. I was on the staff of a research facility. I got an IND number for research on experimental medication. I was on the faculty of a university. So I know about research and citations. And if you create the little drone that can lift 700-pound payload electrically, and then convert it and show that it can lift it hydraulically, and then show that you can make a hydraulic powered drone that can lift a payload of 1,000 pounds and it can fly like an airplane, I think you would get all the citations you could ever want. And so maybe there's a PhD candidate who says, what's my research topic? And I'm showing it to you right here. Go to the National Science Foundation or Northrop Grumman or General Dynamics or DARPA or Special Operations Command. Ask for the money. What I'm showing you here, none of this is expensive. It's not free, but it's not expensive. It's not $1 billion. To go through $1 billion for an electric device that's supposed to fly and then failed, gracious, you can do what I'm talking about here for less than $1 billion. And I will get into plenty of detail. I just feel like LinkedIn gives me 15 minutes. I'll run till the 15 minutes are up and then start again. The drone itself, when it's flying, is going to need to have a jet engine because that's the only thing that can create the kind of power that's needed. But in order to prove that it works, you don't need a jet engine. You can use a diesel engine, just a regular old marine grade for ocean-going vessels. For one propeller, this is about 300 horsepower. I have it driving the pumps, but it could drive a generator. To run all 6 of these and put up a test pad that weighs 5,500 pounds, this would have to be a 2,000 horsepower diesel, which weighs about 11,000 pounds. You're not going to get that on a flatbed trailer. This is a on-the-ground testing facility to look at the propellers. The reason I did this with the 300 horsepower is I wanted to get the thrust output of the propeller with respect to airspeed. In addition, I wanted to drive this up a mountain road and get the thrust parameters for this propeller as a function of altitude, so that as the air gets thinner, we would have statistics on what can the propeller do. Also, how much do we need when the propeller is functioning in fixed wing mode? And this one was made when the drone is flying sideways or just flying along as a drone. It's not pushing itself along with its propeller making horizontal thrust. It's pushing itself along with its propeller making vertical thrust. And so I was curious, how much speed can this propeller have going that direction when the propeller is oriented to be making vertical thrust? And again, you just took it up to the truck and drive off. And that's how you do it. The final one I was interested in was to put this on a test bed. And the reason for that is this drone, and I showed you this before, this drone can fly. It can go up and over this way and over that way, and it can go back and forth like this. But it's got these vertical beams on it that these are attached to the ground. So if this thing decides to do something stupid and crash itself, when it gets to about right there, that's it. It can't go any further than that. It can't go any higher than that. And if it tried to tilt itself over and turn over, it can't do that. So this is a flying drone. And what I wanted to do was take this, it's a little bit too wide to be on the road. So we'd have to take the propellers off or turn it over on its side. But you could take it to a racetrack and drive it around in the racetrack. There's a left turn. So here it is going north. Now it's going west. Now it's going south. Now it's going east. And you could have it in the air and flying. And you could have a person watching and monitoring it. And that would allow you to work through the programming necessary for this drone to have control of itself while it's drone flying. And, the racetracks, they're not going to let you there on Saturday afternoon when they've got races going on, but they'll let you there during the week because they don't do anything during the week. And this whole entire structure is not heavy enough to wreck a racetrack. And again, the little 1,500-pound drone with a 700-pound payload only needs a 300 horsepower engine, and they weigh about 1,200 pounds. So this whole entire structure could be pulled on the racetrack. And I'm going to show you all that. And she said, get off the racetrack. You're out of time. So we'll stop and we'll start another video.